that we just heard, there was a question that he posed. What can we do to actually help some of the Native American communities here in the United States actually lead more happy, productive lives? And what I want to talk to you today is about this co-design approach that the Community Assessment of Renewable Energy and Sustainability has to develop to actually try to address this. This approach tries to work with these tribal nations not as data storage and retrieval systems, but rather as actual researchers, as co-designers, as innovators, as the people that are actually co-designing and implementing their own systems to actually meet their needs. So, and in this process, it's not just us going in and saying, hey, this is the right solution. This is a process in which there is knowledge transfer going back and forth between the interested parties. So I really hope you enjoy this presentation I'm about to give you. But before we go any further, you need to know a little bit about me. I'm a small country farm boy from Alabama. I grew up on a cattle ranch of 126 acres. Every day at 5 a.m., I used to wake up in the morning with my cow dogs to just go out and help round these guys up to really make sure that everything was going well. And then in 2006, I came out here at Berkeley because I really want to actually see if I could use renewable energy technologies to really try to make the world better. And in 2008, we were contacted by a Native American community in Northern California called the Pinole Nation. They're a small tribe located near Ukiah, California, about 2 hours away. And it's an amazing tribe. They've had a long history. They're known for a lot of the pommel baskets that they make. Baskets that are weaved so tight that water can barely escape out of them. This is a tribe, much like the Lakota tribe you just heard, that has faced a lot of hardships. Being disbanded, having their land taken away from them, given back to them, then taken away again. And this is a community that's suffering from a wide variety of issues. Issues relating to high energy costs due to fossil fuels usage. Issues related to lots of solid waste pollution on their lands. Issues related to drought conditions in this region. And moreover, housing that has poor indoor air quality. Housing that has no representation of any of their cultural values and provides some basic necessities of their needs. So the question is, how does one go about actually addressing this issue? And this is where this co-design methodology comes into play. The central tenet of this co-design methodology is that both the end user and the outsider, they both have expertise. The end user has expertise on their needs. They know what works for them. Other tenets are that both the end user and the designer, they both control this ideation process. So it's not just us coming in and saying, hey, this is the right way to do this, or no, this is what Berkeley says. What this means is that you have both the researcher and the community members, both are interacting together, sharing this knowledge and information. This also means that we have to get out of our ivory towers and stop pontificating on high and saying, hey, this is what the latest research at Berkeley says. This means we have to actually get out there in the field with the community members and have them crunch the numbers with us in the field. This also means that occasionally we actually have to get our hands dirty and actually do construction. This means that we have to be able to work with them to move these things around and occasionally swing a couple sledgehammers or two to actually get things built and done. This is what co-design is about, because you cannot have the researchers stay in the lab and crunch the numbers while the community members just do all the manual labors. It's where both parties are actually doing this work together. So the question is this, well, how does this whole co-design approach actually work? Well, it starts off with this basic round-robin session, where the goal is to make sure everyone's comfortable with talking about the topic at hand. In this case here, the topic at hand is technology. Everyone's got experience with technology, whether you consider it to be a basic presentation remote, to shoes, to your basic chair. That's your version of technology. And the goal is to make sure that no one has dominion over this. I can't say because I'm an engineer, but I own this. Everyone has dominion over this concept of technology. Then what it moves over into is this split user needs assessment of what are the most important concerns of this community. And this moves into really trying to figure out, well, how do you actually address some of these needs here? And what you'll see here is actually members of a community, in this case some Pinole Nation youth, actually explaining what are their most important concepts when it comes down to this framework of sustainability. But what was really amazing about this was that we realized that these community members, they have a lot of knowledge in themselves. They knew about natural daylighting system. They knew about photovoltaic technology. The goal is that they wanted to help to actually design and integrate their cultural needs into these technologies. But moreover, what I really realized is that their framework for sustainability is different than what we talk about here at Berkeley. We talk about a lot about greenhouse gas emissions. We talk about natural resource consumption, but we never take the time to step back and really see how do we frame this in terms of a local context of a community. And this was what it was amazing to me to realize that when they talk about sustainability, this goal is on tribal sovereignty. It's about economic independence. It's about environmental harmony. And this was really amazing to us. But moreover, what was amazing to us was the ideas that they already had about the actual designs for what the sustainable housing system should incorporate. Ideas such as having photovoltaic materials, ideas such as having wind energy, ideas such as having geothermal heat pumps, or having design that embeds everything in there. This was amazing to us as engineers because we didn't even know what they had in mind. And I got a question. Do we have any architects in the room right now? Oh, boy, you guys are going to hate this next slide. So the goal is, how do you actually integrate all of these things together? Well, this is what we came up with as a team. When the Berkeley engineers and some of the community members came together, this was the design we created. Looks kind of crappy, right? You can be honest. You know, there's some duct tape on there, a coffee cup sleeve. This is the salad tin we actually took from our advisor's trash can. You know, it's a kind of a crappy design. But for us, what we realized is that we want to make this solution accessible. So we believe in a lot of low-fidelity prototype. And it looks kind of crappy, but it was amazing because the community realized this is the first time someone took time to embed our needs and actual designs. Needs such as having green roofs to actually grow some of their medicinal plants. Needs such as having natural daylighting materials. Needs such as having a rounded-like shape which wards off evil spirits. This was amazing to them. But the question really is, does this co-design methodology actually work? You know, there's a difference between what people say and do. Did they really want to adopt this? So one good thing was in 2009, we were able to come back and we saw this. This was amazing to us because the community members, they took the initial concept that we co-designed together and they decided to modify this and make their own version for their greenhouse. They didn't ask us anything. They didn't talk to us about any equations. They didn't ask us about how to build this because they knew it all. Because, as I said before, they were right there with us, crunching the numbers on the force analysis, doing the analysis to really see what's the modulus of elasticity of some local redwood materials. They knew enough about this to actually design their own system. And the next step was, well, since we understand the basic principles, how can we really take this and really refine this into a concept that we can actually get built? And so this is when we brought in our architects friend to really help us out and really get this design down together. Again, the goal is not to have Berkeley students leading this charge, but to actually work in tandem with the community members. So they're both doing the analysis and the design work with us. And so again, what you see here is community members doing this actual layout. Again, the goal is low-fidelity prototype and actually make sure that the technology that you're designing is accessible. And in 2010, we were able to finalize this design and actually come up with this first version of this culturally inspired sustainable housing design. So this is when we had our architects friends in here to really help us make this a nice design that we can take to the next level. So you see that we still try to keep some of the basic features, rounded shapes here to ward off evil spirits, the usage of straw bale as natural materials, other usages such as having circular items in the middle here to really help with the communication between the family members. And again, integrating the photovoltaic systems into these housing designs. And in 2011, we were actually able to start the construction of these homes with the Panolaville Poma Nation. And it's been an amazing process so far. We've been able to actually weave together and get some of the Berkeley students as well as the community members to learn how do you actually do sustainable construction design using natural materials. And the homes are starting to go up now. And this process hasn't been pretty. Sometimes this process has made me feel like the Joker where I felt that I've gone insane before, because how do you actually integrate some of these concepts such as tribal sovereignty when you have, at least in my case, I'm a farm boy from Alabama. I know nothing about tribal sovereignty at all. But going through this co-design process has allowed us to integrate this. But again, it's been crazy. Sometimes I just want to take my knives and just go after these guys just because it's really been crazy to do. And sometimes they just want to beat me over the side of the head, because you have to go through this co-design process where you're both challenging each other's understanding and frameworks of what sustainability actually is and what are the social performance metrics that should be integrated in this. And it's been made possible by having a great network of team members, networks of members at UC Berkeley that are dedicated to doing this work, networks of undergraduate student researchers and community members that are also really believes in this is how engineering should be done, not from the ivory academic tower, but actually in the field with the community members, going back and forth, weaving the engineering criteria as well as the social and economic criteria. Community members that you actually see in community members and engineers working in tandem to actually get these things done. And it's been an amazing process. And I just really want to say thank you for coming out today. I hope you've enjoyed this presentation. And the biggest takeaway that I have from all of this is just to realize that there's no one real concept of sustainability. There's only frameworks. The key is how do you actually go out and understand the different frameworks that different communities has. And in my case, I believe this co-design methodology is this way to go about it, because without doing this, I wouldn't be here today. The design that we would have created would have been a Berkeley design that the community would never have adopted. So I thank you for my time, and I wish you the best time ever here at this TEDx event. Thank you all.